Super cool problem. So we're asked to replace the question marks in a string to minimize its value. And our string S has either lowercase English letters or a question mark. Now, we have a cost associated with each of the characters inside of our string. So that means that the cost of a certain character is equal to the cost of that character that appeared before it plus 1. And we're asked to return a string with the smallest cost possible when all of the question marks are replaced with English letters. So a very simple example of that would be AAB. The first cost of the first A is equal to 0, the second A is worth 1, and the first B is worth 0. And there's no question mark, so there would be nothing to change, so we would just return AAB. Let's look at a couple more examples. First one's going to be a little bit easy as well, and then we'll look at a more complicated one. So we have this A, B, and then question mark, question mark. And the question is, what characters do we want to place in? If I placed in AA, my total cost would be what? 0 plus 0 plus 1 plus 2. So 3. And that's not going to work, right? Because I could technically put in here, I could put C and D, and my cost would be 0, right? I'd have 0 plus 0 plus 0 plus 0. The question is, how do I know which characters I need to insert? Well, this looks kind of like a problem where we want to count the occurrence of all of the different characters that appear in the string before the question marks. And then, based off that, decide which character we want to insert for each question mark. So when I was approaching this, I immediately thought a priority queue. And a priority queue is basically just going to maintain an order based off of a priority. And in my case, the priority is going to be based off of the occurrence of each character. So when I start this out, A would have 1, B would have 1, and everybody else would have 0. And then when I hit this first question mark, what I can do is draw from my priority queue, what is the next character we have? And we're going to go lexigraphically up if they are of the same number of occurrences that I could possibly put in for this. So I would have my queue, it would probably go C, D, E, F, etc., blah, blah, blah. And at the very end would be A and B. So I would grab the first element, and I could say, oh, that goes for the question mark in the first one. And then I would increment this by 1, because now I have 1C. Then I would go to the next one, and since C now has 1, it would be moved to the very back of my priority queue, and D would be the next one, right? Now this doesn't quite work immediately because of an example like this one. If I go through this and I create a priority queue based off of the counts of each of the characters, this is the alphabet up through Y. That means that my priority queue, when I initialize it, it would go Z, and then A, B, etc., going all the way down. I could come to this question mark here and go to my queue and grab the first one, and oh, Z goes here, right? And then lexigraphically, Z would now have 1, so Z would be moved to the end of my priority queue, because if you have equal priority, my tiebreaker would be what order they are in the alphabet, and then I would put A. This is the wrong answer, though, because A is smaller than Z lexigraphically. So the actual answer I would want is A and then Z. So we need to account for this. So what I'm going to do is do this exact same thing, except I'm not going to build my string as I'm going along. I'm instead going to tabulate the number of each character that I want to add. And then I'm going to, at the very end, go through my string again and add my characters accordingly. And that will assure that it is in lexicographical order. So let's think about what's the big O for this. Well, inserting into a priority queue is a log of the size of your queue. But my queue is going to be a constant size of 26. So each time is going to be a constant amount of time to insert. Okay? I go through my string one time to get the occurrences of all of the characters that are not question marks to initialize my priority queue. And then I go through it again, incrementing my stuff. And then again, I go through and change the question marks. So that's 3 big O of N operations. Now, since I'm going to be using Python, I don't really have an option of doing this in place because strings are immutable in Python. If you're using another language that allows you to modify strings, then you can probably get this done with a constant extra space. Let's get to coding this. So I'm going to just import a priority queue, and I'm going to import a counter. And here we go. We're going to initialize my little hash table. I suppose it's the same thing as a counter. Basically, my hash table is equal to counter, and then I want to put in the occurrences of all of the different characters that are other than a question mark. So s dot replace, and then a question mark, and you can probably actually ignore that step now that I think about it. I'm going to initialize my priority queue, which is equal to priority queue, and that's just going to be it. Now what I'm going to do is go through and add all of my elements to my priority queue based off of their occurrences, right? So first I'm going to load everything on. So for I, C, in enumerate, and then I want to go through all the lowercase English characters. So string.ascii lowercase. I'm going to now go pq dot put, and what am I putting on here? Well, I'm going to put on the count of each occurrence. So that's what this did. When I did a counter of this, it's going to basically initialize a hash table that contains the count of each, the number of times a character appears inside of this string. So I'll go hash table of my parent character, and then the index of that character inside of basically the ASCII string lowercase. And this is just a tie break, because you recall priority queues in Python do run into an issue where you have elements that have the same priority. How does it sort them? It wants another tiebreaker, basically, and it needs to be a unique number. And in my case, that's just going to be the occurrence location inside of string lower ASCII. Then from there, I'm going to just put on the character. Okay, so that's my priority queue initialized. Now what I need to do, I need to think about, okay, how many times am I going to add on each of these characters, and how do I maintain a store of that? Okay, I'm going to initialize basically a default dictionary that I can just increment. So new chars, these are going to be the characters I want to put on, is equal to default dict, it's going to be an integer, so it's going to start at 0. And now let's go through our string and actually figure out, where the question marks are and what characters we want to insert. So for J, see, I'm using J because I used I up here before, and I want to actually pull out I later. So in JC, in enumerate of my string, what am I going to do now? Well, I don't care if it's a regular character, right? I already took care of that inside of this hash table up here. I only care if it's a question mark. So if C is equal to question mark, what am I going to do? Well, I need to get basically the tuple that I have that's at the very front of my priority queue. That'll be the character that has been used the least at this point. So count I, LC for lowest character, I guess, is equal to pq.get. Okay, so I'm getting the top of it. Count is going to be increased because I'm now adding one of them in place of the question mark. And then new chars LC plus equals 1, basically incrementing, okay, I have actually increased the count for this one, and I'm going to go through this later. And now I'm going to put everything back on my queue. And again, this is a constant time operation. So queue.put count I for its index inside of lower string ASCII, and then character. Okay. So this was big O of n up here. This is also big O of n. Now we're at the point where we need to build our answer. So I'm going to say answer is equal to empty string, basically. Now I'm going to go through the characters in the original string I was provided again. So for C in S, if C does not equal question mark, what am I going to do? Ans plus equals C. If I don't have a question mark, I'm just putting the character that was originally there onto the string. Okay, what about when I'm done though? Or, excuse me, what about when I have a question mark? Well, now I can go through, and there's probably a more efficient way to do this, but this is just how I did it because of the time limit for the competition. So for char in string.ascii lowercase, if this character exists inside of my new characters, and it is bigger than 0. So because I'm using a default dict, I don't actually need to check and see if it's in the keys, because if it doesn't exist, it's just going to initialize it at 0. So new char is greater than 0. What am I going to do? Well, I need to decrement this because I'm adding one of the characters to my answer. So new char minus equals, excuse me, not question mark equals, -1, and then ants plus equals char. And I want to break here. I don't want to keep looking after I've added one. And then all we need to do is just return the answer. So there was another way I saw people doing this, which is nlogn. You can technically get all of the characters that you would insert and then sort them to ensure it's lexicographically there, but this should be big O of n. Let's try running this. Assuming I didn't make any coding issues. Okay, we passed both test cases, so let's submit. And we solved the problem. Not many people have attempted this problem yet. Thank you.